Okay, so this is the 2-unit paper for 2024. Just happened a few weeks ago. Let's look at the multiple choice section. Okay, consider the function. Which of the following could be the equation of this function? Well, okay, so it's like a negative slope and a positive y-intercept. So, did everyone get C?
Yeah.
Okay. In a group of 60 students, 38 play basketball. Cap. 35 play hockey, 5 do not play either basketball or hockey. How many students play both basketball and hockey? I guess it's one of those ones where, like, even if you couldn't figure it out, you could probably try the answers. So obviously students that play both basketball and hockey have to be less than those who play basketball. So the answer can't be 55. But, you know, and 5 students do not play either basketball or hockey. So if you have basketball and hockey, you want these people. This whole thing here is 38. This whole thing is 35. And you have 5 that don't play either. So then this whole thing here is 55, right? So the whole thing here is 55. And I guess you just need to come up with a number that's consistent. So if it's like 8, this is 30, and this is 27. And that does not give you 55. If you do like 18, then this will give you 17 and 20. And this does give you 55, 35, 55. Yeah. And if you put 13, you could probably also solve this as a condition, but did you guys all get B, 18?
Yeah.
Yep.
Okay. I'm not necessarily doing these at the right speed, but okay, so peers marked in Year 10 assessments are shown. The scores for each subject were normally distributed. Okay. And which subject did peer perform best in comparison with the rest of Year 10? Okay, so peer performed above average in all of them. The question is how much above average. So here it's 2 standard deviations, and this is not even 1, and this is very little, and here it's like it's like almost 1.5. So it seems like peer performed in English. Did everyone get A?
Yeah.
Okay. It's gonna be pretty embarrassing if I get one of these wrong. The parabola y equals x minus 3 squared minus 2 is reflected about the y-axis. So this is x minus 3. So it's like this. Something like that. It's reflected about the y-axis, so I'm going to turn it into like that. Yeah, so when you reflect it about the y-axis, that's the same as switching x with minus x. So you should get minus x minus 3, so it becomes this. Wait. Oh wait, hold on, I'm like not reading the question. This is then reflected about the x-axis. So then it's like this, you know. Yeah, so reflecting about the x-axis is changing y to negative y. So basically you get y equals x plus 3 squared minus 2, and then you make a negative y. So then y equals negative thingy plus 2. We should probably check quickly that sounds right. So it's a sad face, yeah, so it's a negative, and then it's on the left side, so it's plus 3. And they're both plus 2, so do you guys foresee? You guys foresee?
Yeah.
Okay. What is the integral of 6x plus 1 cubed? So remember, this is kind of like the derivative of 6x plus 1 is just 6, so you can really easily achieve that by dividing by 6. So if you times this by 6, 1 over 6, then you have the derivative right there. And whenever you have the derivative, you can treat it like x. So then, if it's then it's a quarter 6x plus 1 to the 4, and then we times it by 6. Yeah, so to check this is correct, you would just need to differentiate it to get back to 6x plus 1 cubed. So you could do it without actually even solving it properly, because it's multiple choice. So this gives you A, I guess. You guys get A, 5A.
Yeah, but I just differentiated all the options.
Oh, okay. Yep. Okay, what is the domain of this function? Okay, so domain, when they say domain, they really mean natural domain, okay? So domain is some weird, so the domain is meant to actually be given to you. So the natural domain is the biggest kind of domain you could have as a subset of the real numbers in some sense. Sometimes big doesn't make sense though if you have like lots of random pieces. So here you're not allowed to square root a negative number, and you're not allowed to divide by 0. And so you could test some things here. So obviously this is wrong because it's got 1 and negative 1, which make it divide by 0. For the same reason, this is wrong. Okay. And now the question is it whether it's bigger or it's smaller? Well, so the smaller one, so that's interval notation, yeah. So the smaller one will give you negative numbers, because if you have like if you have a quarter minus 1, you get a negative number. So the bigger ones, though, when x is bigger than 1, that'll give you positive numbers. Yeah. So did you guys get 6D?
Yeah.
Okay, so the diagram shows the graph y equals f of x, Which of the following best represents the graph f of 2x minus 1? Oh. I didn't know this was even in 2-unit. This used to be a 4-unit kind of thing. So 2x minus 1 is kind of like a straight line. So it starts a bit like yeah, you just need to try some values. So for example, when x is equal to, so when x is 0 here, the output 0, right? So f of 0 is 0. But here you need to input, say, like a half to get 0. So you need the half to output 0. And already that eliminates A and D. Let's see. So you also want the two output 0. So here when x is also 4. So when x is like 1.5, that should be 0. See? Okay, so that's good. Maybe we should look at a difference between B and C. Okay, so one difference in B and C is here when it's 3.5, it's 0. And here when it's 3.5, 2.5 isn't big. So here, when you put 2.5, you get 5 minus 4. So 4 is 0 here. Yeah, so it should still have. Yes, the 0 should have moved to the right. So then it looks like it's going to be this one. I mean, you could check something else just to be sure. Like, for example, like what happens when x is 0 here? It seems to be really negative. Whereas when x is 0, you just get f of negative 1. Okay, that seems to agree. And then, but here f of 0 is positive. So, alright, you get question 7C. Here's your C.
I got B.
Hmm.
But what I did was I just said this function looks like sine pi x over 2, and then just subbed in f of 2x plus 1. Oh, it's minus 1. Never mind. It's B. It's C.
Okay. Alright. Okay, so question 8. Some data are used to create a box. Oh, I can't. For some reason, box plots, not really. Like they only ever show up in tests, huh? Histogram is created from the same set of data. What? What box plot do we get even? What? It's not labeled with anything. What's a box plot again? It's like the it's like the range, and these are the quartiles, and that's the range. That's the extreme thing. No, this question is bothering me. So yeah, so it's the minimum, maximum of the 3 quartiles. Which of these histograms is not possible? So these are like 0, 0. Oh, so it doesn't matter what the data is. It's saying how many of each there are. So C looks pretty funny. So does D. Wait, I'm kind of looking. I don't know, if I was in the test, I'd probably just skip this question and come back later, but like, it's probably not good. So I guess the idea is the median is in the middle. The quartile, wait, is this meant to suggest that the quartile is not quite in the middle? It looks symmetric.
I think it's saying that the gap between the minimum and the first quartile is 1, and the gap between the first quartile and the median is 2 because it's bigger.
Right, the gap between what? The minimum.
So, wait, hold on.
Oh,
I
you're
think
saying
it's
it's
saying,
like twice as long, is that what you're saying?
yeah,
So this is kind of to scale. Yeah, so in all of this, this is the median, it's in the middle. This is the median in the middle. So here, I guess here the median could still be in the middle. It's like the average. Wait, is this, how many numbers are here? This is 4. This is an even number. So if it's even, then you take the average of these two. Okay. And then, so let's see. I mean, we could just compute it for this, for example. Like this could be, like 0, 1, 2, 3. So where would the quartile be? You have -3. Is quartile the median? Quartile defined to be the median of the... Sorry, this noise is super annoying. So there's like -3, -3, -2, -2, -2. -1, 0. I guess the median of this would be -2. There's like 0. This would be -2. And -3. It also seems like you only have to do the bottom because the top is symmetric. So it seems A seems possible as the so it's not A. So if you do -3, -2, -1, 0. I just can't even remember the definition of quartile anymore. Okay, so it's -3. -3, -3. -2, -2. minus 1. And then I guess how many zeros are there? We're going to have 2 zeros. That's like half of all the data. And then the median of this is 4 things on either side. It's still negative 2. Yeah, I guess this one is also kind of likely to be negative 2, just because there's lots of negative 2's. And this one, maybe this one's going to get a negative 1. So you get negative 3, negative 2, negative 2. There's 4 negative 1's. So that means the median of this is going to be negative 1. If you add more zeros, it's still going to move over to negative 1. So maybe this is the one that's wrong. So I might say D, but let's have a check for this. So if this one, see, this one's very likely to be negative 2 just because there's so many negative 2's. So you have 4 negative 2's. And then you get negative 1, negative 1, negative 3, negative 3. So that's going to be negative 2 still. So I guess that one was probably obviously negative 2. And so is A. B maybe not as obvious, and then D kind of obviously not. Okay, did you guys get 8D? I read the...
Yeah.
Okay. Okay, so a bag contains 2 red marbles, 3 white. I think we've done this kind of thing before. Jovan randomly selects 2 marbles at the same time from this bag. The probability tree shows the probability for each of the outcomes. Given that one of the marbles that Jovan has selected is red, what is the probability that the other marble he has selected is also red? Oh. Yeah, so if one of them is red also, yeah, so it means it can't be this. It can't be like this route, basically. So if everything's out of 20, this is like 6 out of 20. So this 6 out of 20 is impossible. So we're in sort of these 14 possible cases out of 20. And out of the 14 cases, this 6 is not red. It's only these 2, right? So it's 2 out of 14, not 1 out of 7. I guess we didn't have to do it that way, but they kind of told us to. I mean, how likely is it for knowing one of them is red that the other one's red? So there's only one other red one's left. Out of the 4 marbles. I guess the question is, why isn't it a quarter? Yeah. I guess you could have. There's also there's two. Well, you could have picked either of the red ones as well. Yeah, I'm gonna stick with B here. Should I get B? Maybe we can go back to that one a bit later if you guys get the different answer. Okay, the point Q is a horizontal point of inflection. Let A be the integral of F. How many points of inflection does the graph of A have? So what's a point of inflection? So you want A double derivative equals 0. But there's maybe some more conditions. Okay, so if A, the second derivative of A, so this is the first derivative of A is just equal to F. Right. Alright, have you guys even done this one? Okay, anyway, so A, the second derivative of A is the first derivative of F. So the first derivative of F has to be 0 for it to be a point of inflection. So the first derivative of F is 0 here, 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 and there. Okay. So the answer can't be 5, okay? So it has to be 4 or less. Okay. I guess what makes it a point of inflection? So point of inflection is meant to be a point where it goes from increasing to decreasing. So for example, it looks like that. Because here here's decreasing and here's increasing, so somewhere in between it kind of stopped increasing or decreasing. So here it's so here's the second derivative is 0, and a little bit less than that the first derivative is negative. The first derivative is positive afterwards. So it's changing signs. So the first derivative now is just f. So if f is changing signs, right, that's confusing. So here's decrease. First derivative is 0. And you want to see if just the function itself is changing signs. Um, So when you have the derivative this thing, so if you have the derivative is so in this case this is just f is negative. The derivative is 0. The original thing's changing signs. Something doesn't seem right. So what's the definition of a point of inflection? So it's like you have a graph. Y equals g of x. See, like for example, if you have like y equals x to the 4, right? Then this is not a point of inflection, even though it's like fourth derivative is 0. It's like every derivative is 0 there. It's not a point of inflection. So maybe it's easiest to say that it's a point of inflection, like if it's like y equals x cubed. So that's a point of inflection. And here it still has the second derivative is 0. That's a horizontal point of inflection. So here it's the second derivative is 0. And the first derivative, I guess, is changing signs. So it's negative, it's positive here, and it's, where is the first derivative changing signs? No. So it's this. The first derivative is always positive the whole time, right? And it's 0 in the middle. the second derivative is like negative here and positive here. So the second derivative is what changed signs. Here the second derivative never changed signs. It's positive and positive. So here is not and here is yes. Okay, so you want the second derivative to be 0 and it changes signs. So in the graph of f, you want the first derivative to be 0 and it changes signs. Okay, so this is negative and this is positive. This is positive and this is negative. And this is positive and this is negative. Okay, so these all change signs. So the answer is either 3 or 4. And the question is, does q change signs? So q, it's plus and plus, right? So it doesn't change signs. So q is kind of like, q is like this. Alright, did you guys get B, this 3? Question 10.
Yes.
Alright, so that was a multiple choice section.